Good. So before we start again, I would like to remind you to register with the name that you used in our registration form. It will be easier for us to do the dissemination activities and to the quality of the webinars. So please do that. Today we are going to discuss about 3D printing today and to the next webinar. In this webinar we will refer to what is 3D printing, the basic technologies around it, and what is the application we can actually use the 3D printing for. Our instructor will be Marcos Givaridis from Enable Greece. And if you don't have any questions regarding all the webinars and anything else, we can start the webinar right now. Is everything okay? Okay, so Marcos, the floor is yours.
Hello, everybody. Wait. Okay, yes. First of all, I would like to say that maybe I found a way so we can fix the sound on the videos. We will see when we reach this point. Anyway, hello from me, guys. I welcome you all to our first webinar together. We will do also another webinar regarding more specific things about 3D printing. I'm happy to meet you all, and I hope that these webinars fulfill your expectations regarding the art and the 3D printing appliers on the art. Some words from me. I'm a pre-sales engineer. I work in a robotic company, and I live here in Greece. And I'm also part of the Enable team the last 2 years. And I work as a tutor, or we also do other types of projects. Anyway, so without further ado, I will start the presentation. Because there is a lot of things we have to talk about, and we have to be a little bit fast. All right, I'm sharing the screen. Okay, so hopefully you see just the presentation, the yellow part. It's also my screen. Right. So this is introduction stuff. So let's continue. This is the project consortium, the whole project. We are on the artists and digital skills webinars, and today we are going to do the 3D printing basics. The content that we are going to do more specifically is the 3D printing technology, how it works, what are the different methods of 3D printing, what are the different materials we can use in 3D printing, and all together we are going to decide which methods and materials we can use for a project. Finally, we're going to see 3D printing applications, and we are going to talk about the present and future of 3D printing. And I will try to give you some ideas of how you could create your own art with 3D printing, hopefully. All right, so the 3D printing technology, the manufacturing technologies that exists are the formative manufacturing, the subtractive manufacturing, and the additive manufacturing. The first method is the formative manufacturing, which makes use of stresses like compression, tension, shear to cause the plastic deformation of a material into a desired shape. This process is typically for plastics and metals, like, for example, the plastic bottles that you drink from every day. It's an easy process. You simply add liquid material, as you can see, inside this hole. these outer parts, they are called a mold. Sorry, can you also see my mouse, Julie? Can you see my mouse on the screen? Okay, that's good. The disadvantages of this process is that if the final object is not the desired one, the mold should be recreated for the final object to be recreated and retested. So that's a lot of time. The second method is the subtractive manufacturing, which is an umbrella term for various controlled machining and material removal processes that start with solid blocks, bars, rods, or of plastic, metal, or other materials. They are shaped by removing material through cutting, boring, drilling, and grinding. Now, the disadvantages of this process is that a lot of material is being wasted, of course, because you have the cube and you start subtracting and subtracting material, which means that you spend more material than you actually use. And of course, it's not environmentally friendly. Now, the third technology is the additive manufacturing, which is basically the technology that we use in 3D printing. In the additive process, an object is created by laying down successive layers of material until the object is created. In this way, no extra material is used, first of all, and if something seems wrong halfway, we can stop the printing and save a lot of time and material. Now, also, if we don't like the print at the end of it, we can reprint a new one. So there's a lot of advantages there. Now, let's move on to the process, the way of printing, of 3D printing something. Before the use of additive manufacturing, like 3D printing, we should first create the object in a digital form. So it could be an object we design on our computer, or a scanned object, or a photo scanned object. Like there is, for example, as you can see on the third picture here, there is a way to take a lot of photos of an object, let's say of a burger, and put it in a program and create a 3D part. So these are the three basic ways you can do it. Now, the data of the desired object will be converted into an STL file, and then that file will be sliced by a specific program. This program is called Slicer, and it can be divided into little geometrical pieces. Now, the Slicer, the program, will create the code, the G code, in the file type. So it's a G code file with all the information about the 3D model, dimensions, X, Y, Z placement, etc., etc. And this file will be inserted to the 3D printer, and we will print the final object. Now, the revolution is not additive manufacturing, it is the ability to turn data into things and things into data. In other words, we can think of an object, design it, and make it real in a few hours. It could be just a spare part we can find in the market, or maybe it's taking forever to arrive from vendor, or it is something completely original and innovative we want to create from scratch. On the other hand, if we want something to be changed in an existing object, we can 3D scan it, make the corrections we desire, and print a whole new object. Now, the benefits, some of them I have already told you, for example, the cost and the risk mitigation, but let's go through it fast. It's first of all the speed, because comparing to the other technologies, 3D printing is the fastest one, even for complicated designs, like the third one here, like the fourth one. The cost, so if we need just one piece of an object, 3D printing is the cheapest way to produce it. Even if you need to print the object more than one time in a trial and error mode, it is still the cheapest. The rest of the manufacturing technologies become competitive if you need mass production of an object, and not just 1, 2, 10, even 100, even 100 of something. You may decide to 3D print it and not create a mold about it. Also, the risk mitigation. As I said, the trial and error mode means that small changes could be mandatory for an object to perfectly fit in a place, something that cannot be achieved in the first try. You cannot recreate molds for every little detail you need to change because the process costs a lot of money. So this is a very flexible way if you want to create new parts, custom parts, R&D. And of course, it's very important for art, because in art you always want to change things. Of course, the complexity is the design, as we said. Now, the thing that you see here, this part, I believe that the only way to create this part is with 3D printing, and you can also create whatever comes to your mind. Anything can be created with the 3D printing process. And of course, the customization and ease of access. All right, now question. How many 3D printing technologies do you know? Yeah, maybe if you want, you can write on the chat, but we will also move on. If somebody wants, he can write, but I will move on anyway. So there are a lot of 3D printing technologies to start with. There are the basic ones, the FDM and the SLA, for example. Let's move on. Let me show you those. So, hold on a minute. Yes, this is the FDM process. As you can see, there's a lot of there's a lot of companies regarding this type of process, because it's the most mainstream one. But as you can see, there is not just one, it's more than 10 types of 3D printing. So regarding what you want to do in this field, you can decide what type of process is the best one and the optimal one for your final object. Now, the first process that we're going to talk about, as I said, is the FDM process, because it is very easy to use, it's cheap, and it's a home, let's say, 3D printing method, because you can do it by your own. Now, how this works is that a spool of thermoplastic filament, as you can see the bigger picture here, is first loaded into the printer. Now, once the nozzle has reached the desired temperature on this part right here, the filament is fed to the extrusion head and in the nozzle where it melts. So you basically take the plastic spool, take part of it, put it inside the extruder, and here it starts melting from solid, it becomes liquid, and then again it becomes solid. Now, this extrusion head that you see here is attached to a 3-axis system, as shown in the middle picture, that allows it to move in the X, Y, and Z direction. The melted material is extruded in thin struts, and it is deposited layer by layer, where it cools and solidifies on the bed. Now, sometimes the cooling of the material is accelerated through the use of cooling fans. I think, yes, it's not easy to show you here. So there is a cooling fan here. So after this point that the plastic is in a liquid form, there's a cooling fan on the nozzle, so that it will make the plastic solid again. Now, to fill the area, of course, multiple passes are required, as you can see here. So you go one layer, then the second one, third one, and so on and so forth. All right. All right, let me show you this video. It's just a fast video of how it works. Now, as you can see, the first layer is already applied here. This printer is creating a rim, basically, for a car, a plastic rim, of course, for a toy car. It creates the base and then starts printing the model. And this is the final object. This is the base. We take out the plastic base, and this is what is left off. All right, so this is basically how FDM 3D printing works. And this printer, I believe, is a home printer, so it's really easy to find one on the market. Now, what can we print? Basically, we can print everyday objects like gadgets, tools, spare parts, anything plastic. And depending on the material used, you can print anything you can imagine, guys. So except plastic, there are FDM 3D printers for metal, for example, for metal parts, which are used in the manufacturing industry. So yeah, basically you can print whatever you want. The second one is the stereolithography process. Now, this process is a form of 3D printing technology used for creating models, prototypes, patterns, and production parts. It's a layer by layer way to create things, and it uses photochemical processes in which light causes chemical monomers to link together to form polymers. These polymers then make the body of a three-dimensional object. Now, this is the stand, let's say, an umbrella term again for three different types of SLA technology. The first one is the laser SLA. Now, what happens here is that the laser beam goes through a mirror, and then this laser beam reaches let's say, the pool of plastic. So this is a pool of liquid plastic. And with the heat, it starts solidifying the material on this point exactly. So moving layer by layer, it creates a solid part. This is, let's say, the primal way, because it's the first it's the first technology that the SLA was applied. Now, there are also two other technologies: the DLP SLA, which is basically a projector projecting the whole image of the part. So this way, it creates the whole layer by once, which is much faster than the SLA, the standard SLA way. And the MSLA, which is instead of a projector, we have an LCD screen, which does basically the same thing. So yes, so all of these ways create basically the same part. There are not many changes. Let's see a video so you would better understand this technology, because it's pretty hard to basically explain it, to be fair.
Unfortunately, we cannot hear the video, but you can see the captions.
Oh, let me try to change this. Give me a second.
Okay.
All right. Is it better now?
Not really.
No. Okay. Oh, come on.
Well, maybe it's a connection thing because the video too, we can see it like frame by frame at some points. So maybe it's
Yeah, no, this is because of me.
okay.
Okay, let me lower that. So we'll go through this video with you. So let's go through it together. These are the three technologies, as you can see. As you can see, the DLP printer uses the projector, as we said, the whole layer simultaneously. As we said, they can be very fast and very reliable with low complexity parts. The LCD type printers, as we said, is basically the same, but it uses an LCD screen instead of a projector. Yes. Now this is a basic difference between the LCD printers and the DLP printers. With the LCD printers, the screen, let's say, as you print and reprint, becomes useless because some parts of it. How did he call my? Let me. Yes, the organic compounds are damaging it. So you have to replace the screen after some prints. So this is the standard SLA process. As you can see, it prints point by point, like the FDM process. All right. Moving on. What can we print with the SLA technology? In comparison with the FDM technology, with SLA, we can print more detailed items. So with better accuracy and of course, far more appealing to the eye, which will also look like a final product, like a commercial product that you can find in the market. So as you can see on the pictures, we can create earrings, we can create some, what is this? I think it's a mechanical part. And we can also create dental prosthetics for your teeth. So as we said, very high accuracy and much more detail than the FDM. The third one and the last one that I would like to discuss to show you is the powder bed fusion method, which uses either a laser or an electron beam to melt and fuse material powder together. Now, all powder bed fusion processes involve the spreading of the powder material over previous layers, and a hopper or a reservoir below or aside the bed provides fresh material supply. And then the laser beam, the same way that we saw it in the SLA process, goes on the top of each point and melts this powder, creating the solid metal, the solid material, let's say, but we actually are going to see metal printed right now. Let's see. So this is the laser beam going point by point. The sand is, the powder is already applied on the layer. So basically it starts printing the layer right now. Now, after we finish printing the layer, this is the hopper. This blue thing is called the hopper, which takes the powder and creates another layer. Takes back the excessive powder, and now we have a perfect layer to start printing. And again, reprints the layer. And it goes through layer by layer by layer. So after some time, let's move on. Take out the sand, because this whole powder was not printed with a laser. And this powder is also, of course, reusable because it's printing material. So we don't waste any material. We can reuse this, of course. And this is the final product. Some of the products that you can create it with this technology. All right. So these are, let's say, the mostly used 3D printing technologies. Now, what can we print with the powder bed fusion technology? We can do rapid prototyping. This is very commonly used in mechanical engineering. Commercial aerospace components, because you can create very light parts. You can create medical implants, hearing aids, dental equipment, automotive engines and components, and generally very highly complex and delicate objects. Now, don't forget that here we are talking about professional type of 3D printing. So we don't print just for fun with this type of 3D printing technology. Powder bed fusion can be used on applications that require great accuracy and have specific properties, like metal hardness, for example. All right, so poll time. Which type of material do we use to 3D print models? So hopefully some of you were listening to me on the previous slides, and you can answer on this question. So let's start the poll. I guess I'm going to start it. Okay. All right. All right, we already have some answers. All right. I'll give you a minute, or maybe less. So it's metal, wood, cement, and plastic. Now, what type of material do we use to 3D print models? I will end the poll and share the results with you. Hopefully, you can all see the materials. Most of you, 90% of you answered plastic, and just one guy answered wood. I don't know who answered wood, But the answer is basically everything. So whatever you would answer would be the right answer, basically, or the wrong one, because we can use all of those four materials to print. We can use metal. On the previous video, we saw metal printed. We can use wood, but not just 100% wood. We can use part of the print can be wood, and we will see in the next slides how this is going to be created. We can use cement. There are 3D printers that create homes, that create actual houses, and of course, the one that everybody answered, we can use plastic, which is the standard way to 3D print something. So it's good to answer, it's good that most of you answered plastic, because it's actually the most commonly used material in 3D printing. Now, what would you choose for your project? Would you choose the FDM technology, the SLA, or the SLS technology? This is a rhetorical question because I'm going to answer that. We're going to use the FDM technology, but why? Now, FDM seems to be the most suitable 3D printing technology we can use for a homemade, let's say, project. And of course, it applies to someone who wants to be an artist and create something with art. First of all, it's mainly the cost of the 3D printer and the cost of the materials. You can easily fail several times without worrying about the cost of the materials wasted. And there is also a lot of choices of 3D printers that can be very cheap and rather expensive, depending on what you need. The materials used for FDM 3D printing are also very cheap. Like, for example, a spool of PLA, which is the most commonly used material in 3D printing, costs approximately 20 to 25 euros. And one also very important thing about FDM is that you can, it's very clean to use, like it's, for example, suitable for classroom projects, for kids, and it's office friendly, of course. And it requires a very small space to print. So yes, you can have it on your house or on your office or on a classroom. Now, one of the disadvantages of FDM technology, as we already said, is that you don't have like the great accuracy like the SLA technology. You have poor details, and the final object, as you saw in the previous pictures, is not like, let's say, commercial object would be, but there are ways to create a smoother object that we will see in the next webinar. All right, let's talk a little bit about the materials. First of all, as I said previously, the most commonly used material is the PLA, the bioplastic. PLA is a thermoplastic polymer, which is called bioplastic, because it is derived from renewable resources like cornstarch and sugarcane. Of course, we have ABS, which is a very common thermoplastic used typically in injection molding applications because of its very low production cost and the ease of use. And it has great properties, like, for example, a great impact resistance or structural strength and stiffness, chemical resistance, very good high and low temperature performance, and also it's very easy to paint and glue. Last one is PETG. It's the one that you use when you drink your bottle of water. the standard plastic bottle of water that you can find in supermarkets. And it's a filament crafted from a mixture of polyesters, which contains the same plastic utilized for manufacturing processes all over the world. Now, this filament is ideal for 3D printing because it offers all the advantages of ABS, like the strength, the temperature resistance, the durability, but plus the dependability of PLA. So it's actually very easy to use and very more, let's say, office friendly than the ABS. So as we said, the PLA is biodegradable. So a bottle created by PLA on the first day can look like this. On 1 month, it can look like this. And after 60 to 80 days, it's completely degraded. So, yeah, maybe you would decide to choose PLA instead of something else if you're thinking about the environment. One thing I would like to mention about this picture is that these pictures are taken outside. So if you create something, let's say vase for your plant, and you keep it inside your house, this is not going to happen. Your vase will be there for years and years. All right. Let's talk about a little bit about the special filaments. Now, as you can see, these are some flexible filaments. They're commonly referred to as TP or TPU, and they are known for their elasticity around the material to easily stretch and bend. Now, as the name suggests, this material is elastic in nature, allowing the plastic to be stretched and flexed easily. For example, some filaments can be partially flexible, like a car tire, for example, but others can be elastic and fully flexible, like a rubber band. So, depending on what you want to make, you can find the exact filament that you want. You can find a higher flexibility filament or a lower flexibility filament. Another type of filament is the carbon fiber filament, which is not the same as carbon fiber material because it has some percentage of plastic in it. But it has some maybe they're coming from something important, so give me 1 minute. Sorry for this.
Okay, Marcos, that's all right. So you guys, I will take it from here just for a minute. This is the metal, the carbon filament, which is very lightweighted, and it actually has great results when you put it in your 3D printer. You must be very careful where you buy this kind of spool of filament, because if it's an old one, it can be very thrifty and breaking inside your nozzle and creating problems for your 3D printer. If you choose a good spool, you won't have these problems and you will get this kind of surface, which is very appealing. Marcos, if you're ready, you can.
Yes. Okay, everything is
I was
fine.
just explaining about the spool with the carbon filament, so you can say the rest of the things in the slides.
So, okay, so as Yuli said, it's you have a very increased possibility of oozing. So I wouldn't suggest using cardboard as your first 3D printing material. Maybe you should better understand how 3D printing works and then move to this type of material, because it has a very small parts of carbon fiber in it, which will be very hard to print not, but maybe will create some very bad occasions like oozing, um, which is not best for someone who starts 3D printing. Um, you should you may be disappointed by the results. All right, these are my favorite filaments. These are the metal filaments. Most of these that you can see on the left picture contain 80% more or less of real metal in order to achieve this genuine look and feel. Now, those metal filaments work with most 3D printers, not the cheapest one on the cheapest ones on the market, but if you pay a little bit extra, you can find the 3D printer that creates metal filaments. Most of them are PLA based, so as I said, they are 80% metal and almost 20% of plastic, so you can liquidate them in order for them to be 3D printed. But it is very easy to polish them and post-process them. How do you do it? When the print is done, it looks like clay, like the three parts you can see above. But then you can use some techniques to bring out the metal gloss. Now, a rotary tumbler, for example, is the easiest way of handling the finished part, but you can also use some fine grit sandpaper and polish your prints to your desired finish. The longer you polish, the better the sign, of course. On the right one, you can see some wood filament. Now, as I said, you cannot 3D print 100% wood, but you can print a filament that is partially wood and partially plastic, like the metal one that I've already said. This specific one contains 70% of PLA and 30% of wooden fibers. But from texture to smell, everything feels very real. So this means that wood 3D printed parts can be treated as real wood and can be used as real wood. All right. So, of course, all those special filaments are not used just for the aesthetic purposes. For example, the copper filament has antibacterial properties and antibacterial action, and it has been scientifically proven that it eliminates more than 99.99% of viruses, bacteria, and generally a wide range of microorganisms, which makes copper filament perfect choice to use when it comes to prosthetics. So you can forget things like this on the left and start thinking something like this for the future of hand prosthetics when you break your hand, hopefully. Now, this picture is pretty self-explanatory. So we have the solid filaments, the flexible filaments, and the composite filaments. In the solid category, you can see the classic ones. In the flexible category, you can see filaments like TPU and TPE that we talked about before. And in the composite category, you can see a combination of solid filaments with wood, metal, glass, or other types of materials that create a composite filament with very different properties than the standard ones. Also, in this picture, you can see the difficulty of printing each filament. So, for example, PLA, as you can see, is in the outer circle because it is very easy to print. It's like the standard newbie filament to use when you start 3D printing. But as you move on and you move on, you can use different types of filaments like TPE and TPU, which as you can see, are yellow, which makes them, let's say, advanced 3D printing filaments, which so that when you print them, you need, let's say, some type of experience in order to print something and not fail, like the carbon fiber that we talked about before. So this is a very interesting slide if you want to start 3D printing. It's, let's say, a guide. Second bowl. I will start the second bowl. Okay, so what is the most common type of filament used in FDM 3D printing? I'm launching it, and you can choose whatever you want. Okay, 20 more seconds. I'm ending the poll and sharing the results. Now, most of you were right. So PLA is the most commonly used type of filament, as we said before. It's the most, let's say, user-friendly filament. It's office-friendly filament, so you can use it without the exhausts and other types. You can use it on your own house. And of course, it's also, what I didn't say is that even us, even the Enable team, which has years of experience in 3D printing, we also use PLA filament for most of our prints still. So this is not just a newbie filament, it's a filament to use for general purposes. Some of you answered PETG and nylon. Now I understand the misunderstanding with PETG, because PETG is I think the most commonly used plastic generally in the world right now. So this is actually understandable, and you can also print, let's say, on an industrial base and more professional base. You can print more PETG if you are a company, a 3D printing company, because PETG is, let's say, a more professional type of filament. So, what type of material would you choose? And what type of printer would you choose? Now, the best choice for a beginner, the one that we suggest in Enable, is an FDM printer and a PLA filament. Why is that? Well, the FDM printer and the PLA filament are perfect, as we said, because they are office friendly and environmentally friendly, so you can use them wherever you want. They are very easy to use. They don't require any other type of, any other type of mechanism or extra materials used, or extra extra equipment, let's say. And you can understand the whole process very easily. And also it's the cost part. So now that we discussed a little bit about 3D printing, how 3D printing works, what material do you use in 3D printing, and if you want to start with 3D printing, what type of 3D printer is best suited for your application. Let's talk about 3D printing in art. So, because of course, this is what we came to do, right? So, today we'll be exploring how this revolutionary 3D printing technology is changing the world of art and design. From sculptures to jewelry to fashion, 3D printing is allowing a lot of artists to bring their vision to life in new and exciting ways. We'll take a closer look at some of the most innovative and inspiring examples of 3D printing from around the world. And we will also examine the changes and the opportunities that arises when art and technology converge together. So on this slide, you can see some wall art creations by Herschel Shapiro. On the left part of the slide, you can see those three creations. So Herschel Shapiro is a new, let's say, artist, a newcomer, who is a very talented 3D printing artist and also a TikTok creator, by the way. And he's making waves, these types of waves, in the world of wall art. Now, his unique approach to design and the mastery of the 3D printing technology, Herschel is creating those stunning pieces who are unique on their own. Now, on the right, I don't know, to be honest, I don't know who created those four wall art creations, but they are pretty self-explanatory. They are 3D printed art who can be used as a wall art. So you can easily find those types of 3D printed models and print them by your own if you have a 3D printer, and create this wall art or by your own. Now, from intricate lamp designs to create beautiful and unique light patterns to pencil holders that incorporate details and shapes that would be possible to produce using the traditional manufacturing methods. 3D printing is also enabling us to create functional pieces that were once impossible to produce. Some of those you can see on the right part of the slide. Very complex design, of course. Now, vases and pots can be designed with several types of patterns and shapes, while shelves can be customized to fit any decor styles or functional need. Now, these items do not only serve as serve the practical purpose of them, but also demonstrate the endless possibilities of 3D printing in the world of art. All right. Now here is where it becomes personal, and I will explain why at the end of the presentation of this slide. Now this stainless steel metal bridge is created by MX3D, and it's created to represent the potential of 3D printing technology in urban design. Now, the bridge's complex geometries are made possible with 3D printing, and its minimalistic design fits well in urban environments. It's made entirely of durable, resistant stainless steel, and it's both lightweight and strong enough to support pedestrians and bicycles. The manufacturing process is precise and efficient, using robotic arms to extrude stainless steel. And of course, it's extruded layer by layer, like a standard 3D printer. But instead of this printer that we saw before, it's a robotic arm that extrudes the filament. And of course, it's metal filament. Now, the bridge has received multiple awards for its innovation and sustainability, demonstrating the potential of 3D printing in architecture and urban design. Now, the reason I said that this is personal is because actually I've contacted MX3D when I was searching for a job, I think 4 or 5 years before. And they were creating this bridge when I contacted them. The first time I talked to them, they were on the process of finishing this bridge, and they were also creating other types of metal 3D prints. So this showed me that 3D printed had a very huge field of appliance. Now I applied to work there. They are in Netherlands, by the way, and I applied to work there, and they didn't take me at the time, but they wanted to take one of my friends to work there. The fun part is that he didn't go. I wanted to go. Now, by the way, I'm working with this guy. We're working together in my company. So that's fun.
Their loss. It was their loss.
Yes, sometimes life is makes fun of you. Anyway. So let's move on. Let's move on to the sculpture art. Now, with the rise of 3D printing technology, artists are able to create stunning sculptures with exceptional level of detail and complexity, as you can see. Now, on the next slide, on this and the next one, we will explore some ways that 3D printing is transforming this world of sculpture from traditional to contemporary. Now, we look at some of the most remarkable 3D printing sculptures right now, and the benefits of using 3D printing technology in sculpture art, and of course, the challenges that come with this medium. All right. Now let's talk a little bit about some sculpture artists. We're going to talk about those two and one more in the last slides. Okay, the first one is Satumina Sauraharvi, I think. She's a Finnish artist. She's from Finland, and she's known for her intricate 3D printing art. Now, Satumina designs not only showcase her creativity, but also use sustainable materials. Sustainable materials demonstrating the potential of 3D printing to be an eco-friendly medium. So most of her art are created by PLA, the one that we talked before, the material. And her works have been exhibited internationally, and she has won awards for innovation and design, inspiring others to explore the possibilities of technology in art and design. Hopefully, she's going to inspire also you. Now, the next one is Makl Masmeyer, Hans Meyer. And we're going to talk about the digital grotesque project. Sorry for mumbling, but this is very hard to talk about. The words I don't even know how to pronounce them. So yeah, I'm sorry about this. Okay, so we are going to talk about the digital grotesque project, which is all about exploring the expressive potentials of digital technology. Rather than focusing on functionality, this project creates a lavish and exhilarating, it creates very intricate different shapes, inviting us to imagine new spatial experiences and sensation. So it tries to showcase the potential of 3D printing to create unique and immersive work of art. So I think the next slide I have a video. All right, let's see the video. And while we see the video, I will explain how this project is created. What is, let's say, the process behind this work of art. So first of all, the way they create it is with fused filament, bed fused powder bed fusion. Oh, why did it stop? Okay. They use the powder bed fusion technology, like the video we saw before, and they create those very intricate shapes. But how are these shapes extracted? That's a very interesting part of it, because there wasn't somebody who decided to create this. An artificial intelligence architect created this, who is also an artist. So they created a program which took every type of, let's say, 3D architecture they could give it, and this artificial intelligent artist, let's say, started creating 3D models. And from those 3D models, they decided to print, let's say, the most exceptional ones. So the model that you see here is not created by a human. It's created by a machine. It's created by the mind of a machine, the artificial intelligence, and also designed and printed by another machine, a 3D printer. Now, the very interesting question about this is this art? Because it's mostly created by machines. And I think that it's better to answer it at the end of the presentation. But in my opinion, it looks like art. All right. Now, some existing applications, except the ones that we talked about. Silent orchestra is one of them. The mellifera and the 3D printed beehives. Now, on both of them, artists are using this technology to push the boundaries of traditional art and create unique and inspiring work. Example is this of the 3D printed replica of Michelangelo, which showcases the ability of 3D printing to recreate iconic works of art with incredible precision and detail. We're going to see a video about it on the next slide. But let's take a closer look on the existing applications of 3D printing. The silent orchestra, for example, is the one that you can see on the upper right corner. It's created by Peter Lang, who was able to create a room sculpture as a sound absorber called silent orchestra with the help of 3D printing. Now, this unusual art object with a sound absorbing function consists of tubes of different sizes, of course, as you can see, arranged in a honeycomb pattern. So basically, this is a sound diffuser, a sound absorber, but it's created with 3D printing, and it's also in an artistic form. I think I read that when I read about it, they said that some types of sound absorbers are used, for example, in operas and places like this, just for sound effects. Another one, very interesting, is the 3D printed beehives. Another way to call them is the Malifera, which is an installation of swirlings, 3D printed beehives dancing through the Fortnum and Mansell atrium. This is how this building is called, and it aims to highlight the need for rewinding from our urban spaces. Now, the 3D printed modules will make their way up to the atrium until the end of it, to the ceiling. They're made, of course, with bioplastics, again, PLA, and will showcase the advances in material innovation and technology. Okay, now the next slide is about the Michelangelo replication. Michelangelo's David replication with 3D printing. Now that's a very interesting procedure. Actually know that. Let me move on. A lot of people talked about it. So let's see the process. They are start to 3D scanning every part of the model. Of course, those 3D scanners are very expensive equipment. But the more expensive equipment, the more accuracy you have with this type of equipment. But you want to replicate such an important and interesting statue, you want the best equipment. After 3D scanning, they pass it through the computer and they see point by point if the 3D model is perfectly aligned with the actual sculpture, recreating the whole sculpture in a 3D model, as you can see here. And after recreating it, they start printing it. You can see the 3D printing process here. As you can see, they print it in parts, of course, because you can't print the whole thing. And to make it look real, they apply clay on top of it, or cement. I don't know what type of material this is. Okay, they created it. So this is kind of useless, to be honest. Now they're taking the model. Model to the Dubai Expo. Okay. I thought we would see the final product, but that's not the case. But you get the resume. All right. Now, another very, very interesting artist that I found is Sebastian Errázuriz, who is a Chilean artist known for his stunning 3D printing sculptures and the way that he challenges the traditional art forms. Now, he often uses innovative materials such as 3D printing copper, resin, to create those intricate and detailed pieces. But the interesting part is that he creates sculptures often that have political or social message, addressing issues such as consumering or climate change. His work has been exhibited in galleries and museums around the world, including the Museum of Arts and Designs in New York City. And all those sculptures that you can see on the pictures are there. They are on the New York City Museum of Arts right now.
Can you hear me? Is that Marco's problem or is it my problem?
I think Marcos
Yeah.
frozen, yes.
Okay. So if everybody is here, let me just repeat what I've already put in the chat. After we end this meeting, which will be in like 10 minutes, you will have the evaluation form of this webinar opened automatically to your browser. But if you wish, I already gave you the link, so you can fulfill it. Please do so, as I said, with the original name that you have already registered previously to our webinars. This is important for us, so we can check if we have all the evaluation forms from people that are already registered in our webinars. So again, please change your names if you have to the original names that you have already registered. Is there any questions regarding this webinar or anything you want to add or something you want to know about the next webinar? You can put it in the chat. You can just unmute yourself and ask away. Okay. Does this webinar seems all right to you? Are you happy? Did you understand about 3D printing? Okay, again. Thank you, Marta, for your answer. Thank you, Daniel. I'm just hoping that you can use these ideas for your art too. So if you need something to get you started, of course, you need to be to the next webinar so you can see the basic steps you need so you can actually start 3D printing with just a simple home printer. And then we will be at your disposal at any time so we can help you resolve any problems you have, and you can start printing on your own if you do own a printer. Hello, Marcos again.
Hi, can you hear me?
Yes.
All right, great. Okay, sorry for disconnecting. I had an internet issue. What am I sharing? Wait. So you'll tell me. Okay.
Right. Yeah.
Are we okay?
Okay. Yes.
All right. Yes. Go through all of it. Okay. So we were talking about Sebastian Errázuriz. Now, Sebastian created, as you can see, yes, that's what I was talking about. You can see Elon Musk, Mark Zuckerberg. So the thought behind this is that these people are people of power, and the same as the ones depicted in the actual sculptures. So the thought behind it is that same people depicted on the sculptures that we see today, the sculptures from ancient Greece, for example, or the ancient Roman sculptures, are depictions of people of strength. So you can see on their faces the faces of Mark Zuckerberg or Jeff Bezos, generally the faces of people who have power. So in my opinion, the thing that Sebastian Errázuriz wants to show is that maybe the sculptures that we all praise and think of them as so special and unique are sculptures of people who had great power, and people who maybe to create this great power did, let's say, bad things to achieve it. So yes, this was my favorite one because it also showcases how easy it is to create something like this. So what Sebastian did is that he took, or maybe 3D scanned those types of sculptures and put the faces of very important people of our time. And you can also do that. It's not something very, out of your league or something that requires a special skill. It's something that you can do and you can master in less than 1 month, in my opinion. Well, not master, but at least understand how everything works and actually do an application of this. All right. And this is the last poll, I think. So let me start it. Sorry. All right. So the question is, which 3D printing technology is best suited for creating large-scale sculptures? Is it the FDM, fused deposition modeling? Is it stereolithography? Is it SLS, the laser, the selective laser centering, which is the one also used? Well, let me help you in this. This is also very close to bed fabrication, bed fusion fabrication, but I don't know how it's called. Powder bed fusion, yes, the powder bed fusion type. Or is it the digital light processing, the DLP? Okay. Still people are thinking and choosing. So I'll wait for half a minute more. Okay, 10 more seconds. Okay. Let's share the results. 54% answered fusion deposition model. This is the right answer. Let's go back to Michelangelo. So as you can see, the 3D printer here creates the whole head. And to create the whole, you need a lot of space. And to have a lot of, and for a lot of, let's say, a lot of build space. And FDM 3D printers can be created to print in a big space. Can you see how big this head is? This is
So we have a problem again, as I can see. Unfortunately, this happened at the end of the webinar.
Probably, yes.
I really, I will stop sharing this so we can have a.
I agree, Julie.
Okay, and let's stop sharing Marco's screen if we can. Marcos is still in. Okay, now. Now.
I think, Julie, that we can complete
The webinar.
we can finish the webinar. Yes, okay. I think Marcos has finished actually the presentation. It's okay. He has connection problems. We can understand.
Let's wait like 2 minutes so he can come back and say goodbye to everybody.
Okay. Yes, of course. Of course. Yeah, the presentation was really interesting. I like it a lot. Yes. I really like the Michelangelo. Yes.
All the applications for me, it's very interesting. I hope for you too.
It's amazing how many different ways you can think to use the 3D printing technology also in the arts field, and how many different things you can create for different target groups.
I think like 2 days ago, I came across a TikTok group that in India actually 3D printed houses at this moment, where the problems there with accommodation are very big. And now we can 3D print very, very good looking houses, to be honest. I'm not sure how they endure to, I don't know, earthquakes.
The earthquakes, yes.
Yeah,
The
but
durability under such situations, yes, it's something that only time can,
tell us.
yes, can approve the durability.
But it was a nice, small, cozy places, not like multi-flat, just one small house. Marcos, are you here? He's trying to, but I can see he's frozen again. Okay.
Yes.
You hear us?
Hopefully you can hear me.
Okay, don't share any. Do you have more things to? Don't share yours because I can see you have a lot of connection problems, but I think you have already concluded with your presentation, right?
Yeah, well, I have one more slide. Let me show.
Okay.
Let me show.
Okay.
So this is the last. I will show it here. Okay. So this is the last thing that I wanted to discuss, because this is something that I was confused about. So what is art? The first answer I found on the internet, let's say on Google, was that it is an expression or application of human creative skill and imagination, typically in a visual form, such as painting or sculpture, producing works to be appreciated primarily for their beauty or emotional power. So the first answer is the one that most of us, let's say, think about art. Like when you are young, you say, what is art? Oh, it's sculpture. Oh, it's something that creates some emotion. But how do you differ this? Like, this is not, let's say, let's say that we cannot agree. Two people cannot agree that something has an emotional power on them. So you can't be sure what is art and what isn't. So I couldn't accept this answer, so I moved on to the next one. The next answer I found is that art is a way to express our emotions and feelings, and it can be used to communicate ideas and thoughts. It can be used as a tool for self-expression, used as a form of therapy, or even as a means to find beauty in life. So that was a more inclusive, let's say, answer. It included the emotions, the feelings, so everything you feel. It was the answer was more of an artist-centered, self-centered answer, because it focused on the artist and not the one that was watching the art or thinking about it. So this was not let's say, whole answer. So I asked ChatGPT to tell me the real truth. And the answer of ChatGPT is that art is a diverse range of creative activities that express ideas, emotions, or beauty through various mediums and forms. So basically, ChatGPT told me that art is almost everything that you can express with your emotions, with your ideas. It's called art. And since my brother was on, he finished how is it called?
What?
graphics design, the graphics design department. They had a lot to do with art. They read a lot of art, a lot about art. And what he told me is that you can decide what is art. Basically, art is everything. So what I wanted to conclude is that you can say that something is not art or it is art, because a lot of people may argue that 3D printing cannot go with art because it's technology, and then with technology you have artificial intelligence, and then when does art stop and when does art begin? I believe that art is everything, even if it's created by humans, even if it's created by a robot, for example. It's art as long as you believe that it's art. So it's up to you to decide what is art and what isn't art. Yes, so with this, I finished my presentation, and hopefully I won't have any more internet connection issues. If there is anything that you want to ask, now I will stop sharing my screen.
Thank you,
Yes,
Marcos,
if there's
for this.
anything more.
So, as Marcos said, do you have any questions?
Okay.
Okay. Thanks a lot. So our next webinar is at the 11th of May, so in 2 weeks from now. Marcos will be your instructor again. You will learn about the basic steps about how to 3D print in your own home printer. I can see no questions. So thank you, Marcos, again. And if you have a little patience, I will end this webinar right now, and the evaluation form will pop up